Great. Okay, let's get started. Thanks everyone for joining today and welcome to today's webinar, Instrument Profiling, How to Effectively Manage Your Fleet of Instruments. Presenting today is Tim Mouw, our Applications Engineering and Technical Support Manager at X-Rite Pantone. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions, please use the questions function on the GoToWebinar panel. We will have time to answer some questions at the end. Finally, this webinar will be recorded and you will receive a link so that you can review this webinar at your convenience afterwards. Usually we actually send that out tomorrow. So with that, I'll turn it over to Tim to kick things off.
Thank you, Robert. Welcome, everyone. Let's dive right in. Our webinars are intentionally made to not consume too much time, but we still have plenty of things to talk about. So let's go in and start talking about instrument profiling and how we effectively manage a fleet of instruments. So first, let's talk about what is instrument profiling. We're going to answer the simple questions, but we'll also get into some of the details. So an instrument profiling is a method of verifying and optimizing your instrument performance. So we're going to verify it, make sure that it's operating properly, and we're going to actually optimize it. And why does that matter? Well, it's to ensure consistent measurement results across the supply chain, which may be small, may be large, could be global, right? And obviously we want to make sure that all of the instruments are performing properly. And it matters because we want to make sure that we reduce the influence the instruments have on what we call an error stack, which might look something like that, right? And to maintain the inter-instrument agreement that we need to ensure accurate measurements. So that error stack, that's stacking up to a total color difference, and the different parts of that block may be different pieces that contribute to our color difference, right? If we get a color difference, there are different causes and effects that are happening. So the orange part of that block might be process variation. The green part might be raw materials. The purple part might mean, I don't know, there are any number of variables, right? And one of those could be the actual instruments themselves. So we want to minimize the amount of the instrument effect of a different instrument's impact on that. So why is it needed? Because instruments can introduce differences due to the environment that they're in. So even if we would take the exact same device and the device itself didn't have any issue in correlating to itself, the same one device, but we put it in 3 different environments, we might get 3 different measurements because, of course, the instrument will behave differently in a different temperature or humidity, right? And so profiling can help us deal with that. And, of course, electronics are not perfectly identical. So if you have 2 devices that were made at the exact same time, the capacitors and the circuits and everything inside of an electronic device doesn't give us perfect identical results every single time. So that's where inter-instrument differences come, and profiling is about minimizing that to ensure that your instrument is giving you a good, accurate, precise measurement. So let's dive just a little deeper then into inter-instrument agreement. So when we're talking about that, we're talking about 2 devices of the same model and how closely they measure to each other. So on the right-hand side, you see 2 benchtop CI7860 devices. On the bottom, you see 2 handheld CI64 devices. We're talking about if we have the same instrument, and they don't have to be absolutely identical. One may have different features in it than another, but we're talking about the same basic model of instrument. How well do those 2 instruments measure to one another? Typically, with X-Rite for sure, and with most instrument manufacturers, you have a published specification for how close those 2 devices will measure to one another. And when they're manufactured, in order for us to manufacture it and sell the product, it has to meet that specification. typically, less difference between devices means a higher price because it's becoming a more precise instrument, if you will. And if we don't maintain that agreement, so let's say we'll use the 7860 as an example. The inter-instrument agreement for those devices when they're manufactured is 0.06 delta E, 0.06. That means on average, two devices will measure within 0.06 of each other, or 0.06 of the centroid, right? And so we want to maintain that because if the instruments start to drift, suddenly a sample, the exact same sample might measure, if they drifted significantly, half a delta E apart from each other because the same sample measured on two instruments gives me half a delta E of difference. Now I'm off starting to try and fix a color problem that's not real because I just introduced one with instruments that may have an issue, okay? So let's talk about how we profile, what profiling actually does. So profiling with X-Rite is something called NETPROFILER, which is a piece of software that walks a user through the process. So I got a couple of screen grabs here to kind of show you that. This is what NETPROFILER software looks like. It is the easiest thing in the world to use because it literally pops up screens and little videos that walk you through what you're supposed to do. And you go through and do measurements and you end up with some measured results for your instrument that you tested. And really quick, I'll show you, you get a performance report. Many customers use this performance report as a means of meeting ISO specifications to show that their instruments are being maintained. This particular instrument that was tested, expected average max DE, you can see down there on the bottom, 0.16, okay? Unprofiled, it was just over that, 0.162. After the profile was applied, 0.06, okay? So what the profiling software is doing is it's testing it and then also correcting it, and we'll see more about how that works in a minute. NETPROFILER also includes tiles, and they look like either the top section there where there's small 2-inch ceramic tiles, that's for a benchtop device. The round ones, same tiles, they're just put into a different format. That's for use with a handheld device. So you have the ability to profile either of those devices with those tile sets. The tiles are serialized, and you get a tile set with a serial number on it, and it's already got its data stored in the cloud. Okay, we'll talk about more about that as well in just a second. So let's look at the process. So you connect your instrument, you tell it the serial number of your tiles, you measure your serialized tiles. Some of the tiles you're going to measure multiple times. It does some short-term repeatability, for example. You'll notice on the report up here, it says for the mid-gray and the deep blue, the expected max DE, that's measuring each of those tiles. It measures them 40 times in a row to see if there's any drift within the instrument short-term, okay? And then it also has us measure all of the tiles, the white, the mid-gray, deep gray, red, orange, yellow, green, and deep blue, generates the unprofiled data to find out where are we. It compares that data to the cloud data. So the serialized tiles were measured at X-Rite in a very controlled environment with a master device. So that means we're going to compare your device in your environment where you're measuring those tiles back to what it was, what the tiles should have been, were measured with a master device in a controlled X-Rite environment. Okay, so we're comparing you basically back to where you would have been when the instrument was brand new being manufactured. And a profile then is created, if it's needed, and downloaded to the device. So what's a profile? A profile is a mathematical adjustment to the instrument to correct for drift that's going on. Drift that happens, why? Because the temperature may be different where you are. okay? Drift that happens because over time, as you take measurements, your lamp will age, right? The lamp is the most likely piece of the device to change over time, because the more you use it, the longer you use it, the more the lamp starts to degrade. And so we can adjust for that. Okay? So this profile is created, and the reason we say if needed, if you measure all the tiles and you're inside the performance of the instrument, then we don't do anything, because there's no reason to adjust the instruments already within spec. Okay? So it might say no new profile. Why? Because your instrument's already in spec. It doesn't need to make any adjustment to the device. That's essentially telling you your instrument's measuring correctly right now. Keep using it. Okay? It'll still be identified as having been profiled for tracing purposes, but it won't actually add a new profile to the device. Finally, okay, after the profile is downloaded to the device, so it's actually stored on the instrument, then every measurement taken is identified as measured with an active profile, giving us an audit trail. Okay, so in our software, for example, there's a little icon that says NP on it for NETPROFILER, right? It will identify every measurement as taken with that. So if you think back to a global fleet or even a smaller fleet of instruments, and you're looking at data measured against the same standard, for example, data measured from different plants, and you're looking at their data, you can very quickly look at the trials that were measured and see that everybody's got active profiles. NETPROFILER, by the way, a profile is active for 30 days. It starts to warn you when the profile is going to expire that you need to go reprofile the instrument. Okay, and it identifies then that your instrument is profiled and that your measurements have been taken with an active profile, giving you that audit trail. It's very easy then to remove the concern. Well, was the instrument in a good state? Right? Without NETPROFILER, you don't know. You can assume that the instruments are all in a good state, but you don't know. With that NETPROFILER signature, that icon on that audit trail, it ensures you that the instrument's in a good working state, okay, and that it's been profiled. Okay? Now, there are times when people go to profile and we can't even get it to profile. That's an indication that an instrument needs to be serviced, because there may be something, maybe the lamp is degraded so far that it can't be corrected anymore. Those kinds of things. So the last question here is, does it work? So quickly, let me show you some data. So these two screens, the left one is specular component included, and the right is specular component excluded on benchtop device. The red area is what those tiles measured in an unprofiled state. The green area is where those tiles measured after we applied a profile. That's to show you the kind of thing that happens. It's reducing the amount of error that the instrument has on a variety of colors. This happened to be done with a full, there's a larger set of tiles that can be used beyond the 8 typical tile set. This is a 13 tile set we used for this test. So let's look at this in a couple of different ways. This is a single benchtop device, and each of those points on that line is a time when the instrument was profiled over a 6-year history. And the yellow is where the instrument was drifting. Now, you might have expected to see something more of a gentle slope from lower to higher, going left to right. The reason you see these peaks is this instrument happens to be in a place where the climate changes, right? So everywhere it's peaking like that is actually summertime, where those peaks are occurring because the environment is a much warmer and more humid environment and that happens to cause some drift to the way the instrument works. What's interesting is that you see these peaks and valleys and a lot of variation between that device from month to month over a 6-year period. Yet if we look at the blue where the profile goes, there's still some peaks and valleys, but we're down in a 0.05 delta E range. So the variation that's going on there is extremely minimized, giving us a very much more repeatable, reliable result. And the last piece of data we're going to look at is the result for a population of 228 benchtop instruments. So we pulled this data anonymously from our NETPROFILER database with varying ages and service histories. So looking at their unprofiled measurements, 51% of the time when they took the measurement of the tiles, it was inside the spec. 49% were outside. So that 51%, those instruments wouldn't have generated a new profile because they're in spec. 49 of them would have. Now, some of these instruments within spec may have been brand new, right? You're profiling over the first few months. Obviously, as an instrument ages, it's more likely that things may drift and so forth. But that's, it's basically a 50-50 mix. So you got a 50-50 shot at taking a measurement with an instrument, assume it's okay, and you got a 50% chance you're inside the specification. When we profile them, it's 100%. Okay, it was a 99.7 or something percent of those instruments after profiling were inside the spec. Right, so you got this tiny little sliver that fell outside. That was a couple of instruments that needed service on them. So essentially, it's getting rid of this 50-50 doubt. By profiling, I can get inside this 100% confidence in the results that are coming from my device. So to wrap that, and then we'll go to some questions. Instruments and environments vary, adding false color difference, right? False color difference, and gives us the wrong answer. Keep in mind, it could be a wrong positive as well as a wrong negative answer. Might say it fails when it doesn't, might say it passes when it doesn't. It could influence or impact us both ways. NETPROFILER ensures instruments are providing reliable and repeatable measurements across a supply chain. That supply chain might be 3 instruments in your one facility, right? That might be you only have 1 instrument and that's all you care about. Yes, but you do have colored data that you occasionally share with suppliers or customers. And so if your instrument is net profiled and their instrument is net profiled, then you at least know that you're sharing same data. You're eliminating that doubt. And lastly, and maybe most importantly, it allows you to confidently focus your efforts on correcting real color problems and knowing that you don't have to worry that the instrument is contributing to that. All right. So let's look at some questions. Robert, do you have another poll question that you wanted to throw up while we answer these?
Yeah, so great. It looks like we already have several questions coming in. If you do have a question, feel free to submit one now. While Tim looks through those and starts answering them, I am going to launch that other polling question. If you are interested in talking to someone for more information, please feel free to respond to this polling question.
All right, so give us the feedback there and I will answer a few of these questions. So a couple people asked about profiling, replacing, or being a substitute for calibration. So let me be clear, there's really 3 things going on here. So the calibration of the device that you do on a daily basis, typically it's every 4 or 8 hours, something like that, right? We still need to do that. Okay, that calibration, white and black calibration, is to set the endpoints of the instrument, okay? So that is still necessary. In fact, you will calibrate your instrument multiple times when you profile it. But sometimes people talk about calibration, they're talking about getting your instrument recertified, sending it to X-Rite to get it recertified. So there are some customers who use NETPROFILER as a replacement for that because they are doing it in your environment, right? There are certain people who need, for example, ISO 17025. They need to meet that. Well, the only way we can do an ISO 17025 calibration of a device is for X-Rite to do that at X-Rite. So recertification is necessary if you need that. But we have people who use it both ways. So NETPROFILER can be useful in doing that. Someone asked about using NETPROFILER and getting that response of no profile generated. that's telling you, and typically you can go look, if you look at the data, it's because the instrument is in such a good state, it needs no profile. It actually measured the tiles within the specification, so there's no need to adjust it. Think of it like I'm calibrating my digital balance, right? And I put a 5-gram weight on the balance and it reads exactly 5.00. I'm not going to do anything, okay? That's kind of what NetProfiler is doing. It's right measuring something and then I'm adjusting it to make sure it gives me the answer it should give me. Another question, how do you ensure that the profiling also works for other colors than the ones in the set? So those tiles are specifically designed to test across the spectrum. And you'll notice when you do a profile that you have a white, you obviously have white and black calibration that's going on as well, but you get a white, you have a couple of grays, and then most of the other colors are very, very chromatic, meaning there's a deep blue, for example, to help us on the low end, but you have a bright red. So it reflects a lot of red energy, but it absorbs a lot of the other energy across the spectrum. So those tiles, when you combine the results of them all together, measure very well how the instrument is performing across the entire range, 400 to 700 nanometers or beyond, depending on the instrument. Those tiles are designed specifically to do that, and they're used by, they are the industry standard for people who produce benchtop or handheld spectrophotometers, those kinds of tiles. So they meet that and they ensure that we can get to those very specific values for those tiles. If we meet those, then we're going to measure well across the entire spectrum. So how frequently should profiles be made? Every week, every month? You can do it more often than monthly. That's 30 days is the way the software is set. The instrument and your QC software will warn you as you start to approach the fact that your profile on your instrument's about to expire. So 30 days is our recommendation. Somebody else asked a question about the benefit to profiling versus yearly calibration. So there's benefits to both. Yearly calibration, of course, ensures that we are functional in a controlled environment to very, very accurate standards. Yearly certification or yearly calibration at X-Rite also includes the instrument being cleaned. It includes new calibration tile for your device and those kinds of things. So there's some other benefits. But what NetProfiler offers you is ensuring your instrument in your environment is functioning properly. Remember that slide I showed where the instrument varied greatly during the year, right? Over 6 years, we saw a peak every summer. So it's about the instrument being profiled for where you're using it. Because when you send it to X-Rite, we're putting it into a very tightly controlled environment and testing it there. And it could perform well there and have not as good a performance when we put it in your environment because, you know, we're sitting at 72 degrees and 51% humidity, and you're going to go use it in 84 degrees and 80% humidity, and that's suddenly going to make it behave different. So profiling is about making sure your instrument works well where you use it. All right. I will answer one more question. I know we have lots more questions than that, but I promise you we will respond to you with answers to all of the questions that have been asked. Somebody asked, is it possible to buy 2 instruments with 1 NetProfiler? So essentially the way it works is NetProfiler is a license per instrument, but you can use the same tile set across multiple instruments. So you have to buy access on a per instrument basis to profile them. And then the tile sets can be shared across instruments. That's not an issue whatsoever because, of course, the tile set is the thing that ties us back to the data in the cloud from our master instrument. So we have We have lots more questions. Like I said, I promise we will get those all answered and get back to you. Thank you for your time today. As Robert mentioned, you will get a copy sent, a link sent to you likely tomorrow with a to the recording of this webinar. I thank you all for your time, and everybody have a great day.
Thank you, everyone. Bye.